Welcome to HB Tuner's GM Gen 5 Training Part 41. In this training module, we're going to be exploring how we can dial in both airflow modes, so mass airflow and volumetric efficiency, at the same time using some math channels and some histograms in our VCM scanner. This is going to be speeding up our calibration process greatly on our Gen 5 vehicles, also making sure that our dynamic airflow, which is the tracking between mass airflow and speed density operation, is going to be very, very close to either airflow mode, improving our transient type of driving conditions, also improving a vehicle with automatic transmission shifting. So this is all things that we want to get dialed in. Let's jump into the video so we can take a look at the overview of how this is going to work. Okay, so let's get started. We're going to be taking a look at how we can dial in our mass airflow and our virtual volumetric efficiency at the same time. This is going to speed up your calibration process, making you a lot more efficient. And ultimately, what we're trying to get after is having our dynamic airflow match what the mass airflow and the speed density are showing at any given time. If we have our mass airflow model and our speed density virtual volumetric efficiency modeling correct, when we go into a transient condition, having a large throttle change or a big burst of airflow, the dynamic airflow is going to take over looking at the speed density, air mass calculation, and then we'll find the dynamic airflow is going to reflect that. It'll improve our transient driving. So if we dial in both airflow models, so they're pretty much on top of each other and they're matching each other, the dynamic airflow isn't going to be drifting further apart from one airflow model or the other, and it improves the drivability. It also can improve things like our torque calculations. So if you have an automatic transmission, your shifting is typically improved. There's a lot of things that start to fall in line on the Gen 5s when we have the airflow model nailed down. So this is going to allow you to go and take care of both airflow models at the same time. This is heavily going to depend on how we set things up in our VCM scanner, and we're going to be spending most of the time in the tutorial here in the VCM scanner, and we'll take a look at a sample data log so we can understand how this is going to work. Now, after we go through this tutorial, this is essentially the setup, getting everything configured. The next two tutorials, we're going to take a look at how to dial in part throttle. So we're going to essentially go back to square one. We're going to go back into dealing with dialing in the MAF and the virtual volumetric efficiency at the same time for part throttle using closed loop trims. And then we'll have another tutorial focusing on our full throttle calibration process, going into power enrichment and getting things dialed in there. The nice thing about this is that we don't have to disable and put our engine control module into the high speed mode where it's MAF only, or trying to put it into speed density MAF failed mode. We can simply calibrate things just as the engine control module sits in its natural state in the programming from GM. This is definitely, in my opinion, the superior way to dial in your airflow models. So let's jump in here and take a look. I just want to cover some basics, even though we had two tutorials talking about dialing in the closed loop operation for speed density and mass airflow. Let's just quickly go over that here in the beginning. So if we jump into the calibration file here, this is my speed density closed loop tuning 3 file that was associated with that specific tutorial. Let's go in here to the engine tab, and if we go from general over to airflow, we have our general tab right here. Now if we take a look under the mass airflow calibration, this is our curve 1 right here. This is what we need to calibrate. So we need to go and take a look at setting a particular frequency versus an air mass amount. Now, if you've changed out your intake from the stock airbox assembly to an aftermarket unit, you will have to go in here and start to touch up the table. Depending on how large of a difference your air inlet assembly is going to be, so how large your MAF housing size change is going to be, you might have to perform that rescale that we've covered in a previous training module using the Excel spreadsheet calculator I provided in the training course, just real briefly here. That's going to be found here on the MAF rescaling page. That's going to be using our measuring your stock inner diameter, your stock airbox, MAF housing size, entering in the new inner diameter of your new intake, and then it'll allow you to go and plug in your mass airflow calibration curve, and the blue here would give you the rescaled amount, and you can simply copy that into your calibration file. That'll give your starting point, and then the fine tuning will be what we do using the log data from the VCM scanner, just as we already talked about. So that's all going to be the same, but I wanted to mention that you still have to go and scale out your MAF curve. Now, at the same time that we have the mass airflow calibration table here that we need to dial in, we also need to dial in our speed density. We have our speed density coefficients here. The VE coefficients are something that is not easily editable. However, we do have, coming up here, edit, into virtual volumetric efficiency, this allows us to actually dial in these VE coefficients. So it's assembling all of these VE coefficients into our... Thanks for checking out our teaser clip. If you want to see the rest of this video and more than 500 hours of current EFI training we have to offer, make sure you click right here. If you want to go and check out more teaser clips from this training course, click here, and you don't want to miss any of the videos we're going to be releasing on this channel, so make sure you subscribe and click here. Thanks for watching, and I'll see you guys later.